buttons on time. That's all for the board's announcements. We're NFA. Everybody who's aspiring students to become tomorrow's leaders beyond academy field. Let's have a great day.
Okay. Any questions on the first two? Yes, great.
I don't see it. Why you multiplied in 17 like by 4 and then...
Are you in the first one?
Yeah.
Okay, why I multiplied everything by 4?
Yeah.
Because here is your fraction. So if you were going to add these together, what would your common denominator be? 4. So I want a multiple that both will fit into so I can get rid of that denominator. So if I pick 2, 4 doesn't go into 2. So if I pick 4, that works. So if I multiply this by 4, this by 4, it's an equal sign. I have to multiply every term by 4, this by 4, this by 4. So 2 goes into 4 2 times 3 is 6. 4 comes out, there's your 1, and it's the same as a 1. 4 times this, we have, oh, this is in parentheses, sorry. If this is in parentheses, you're fine. And then 4 times this guy. Just, you want to find your multiple so that you get rid of that fraction. In this one, out of a 3 and a 4, easiest way, if you want to put this over 1, start with your highest one. Do they all fit into the highest one? Nope, double the highest one. If not, triple the highest one. Work with the highest one, because obviously the highest one's never going to fit into the smallest one. Okay. Okay, with this we had no domain restrictions, so we didn't have to go back and worry about the denominator because there was no variable in the denominator. Stop me if you have any questions. This one, is everybody okay with this? Cross multiply? Easiest way probably. Or multiply both sides by 5x plus 4. Kind of works out the same way. Okay. Now this one has a domain restriction. So when we get the answer, we say it was 4 in our allowable domain. So I know it's okay for my denominator, right?
Georgia Blake Williams, please report to the boys' gym. Georgia Blake Williams, please report to the boys' gym.
Be careful when you cross multiply. Just make sure that you put these guys in parentheses. Oh. In parentheses. Go to my board is wanted. This one? Factor everything first. You basically only have 2 factors. X plus 3, x minus 3. So easiest way, watch. Just put them on the top of every term. I still do this because I like to see what I'm doing, because usually I forget where I'm going and I forget what I'm doing. I do 5 things at the same time. Put it on the top. Watch how easy this is. Take out the one that you have. What's left? 1 times this guy. 1 times x plus 3. Take out the one on the top. 1 times x minus 3. These are both there because this is the same set of factors. So it just equals 10. And now you have a nice little equation. If my answer was 3 or negative 3 from my domain restriction, I would say, nope, not allowable. But my answer is 5, so at least it goes into my denominator. Well, if it really works, you have to make sure that your answer is correct so you can plug it into the original equation. Okay, same with the bottom one. Once you find your common denominator, think of these as factors. Think of this as a 3 and as a 4. You need something that goes into both, so you need both of these. 2x plus 1, 2x minus 1. 2x plus 1, 2x minus 1. And then do the same thing for this guy. 2x plus 1, 2x minus 1. So this guy's coming out. I'm multiplying 7 times 2x minus 1. Watch your minus sign. This one comes out. I'm multiplying negative 8x times 2x plus 1. And this one, I have to multiply both. Those are your perfect squares. If you want to multiply those out first and then distribute, it works out a little easier. Watch this negative sign when you distribute. Collect your like terms. And we do get a lot of fractional answers in pre-calc. And we do get a lot of radical answers in pre-calc. And we get a lot of weird answers that you think, God, you must have did something wrong. No, probably you didn't. As we get a little bit into the course and we start looking at graphs and trying to find where our point is, we have a rule in precalc, we'll go 3 decimals if it doesn't come down to a reducible fraction. 3 decimals is a good, precise place to go to. Questions at all on these? Sometimes it takes us a little while just to get back into it. You had the summer off, you know, you just got to get those math minds working again. Don't panic if you feel like, oh, I'm not getting this and this is review, what's going to happen to me. It'll be fine. It will be fine. Okay. Again, you need an x and you need an x minus 5. Put that on the top of everything. This one's easy. When you multiply 0 by anything, it stays 0. So that becomes a nice little equation. Questions? Yep, I sure can. This is another reason why I record my lessons, so that, you know, like, say you didn't get the whole thing, or you wanted to look back at it, you can just go to the video, go on at Moto, just go to video, and just don't watch the whole video, just move the video to where you need it to.
Is this on?
We're recording. Yeah, recording. Say hi. Ray says hi.
So the link you post on Edmodo is the track
Is the videos.
Okay.
It's in your Edmodo from yesterday. I've been posting them this week.
I couldn't find them.
You,
I couldn't see them.
you couldn't see the videos? Okay. Since we do this, let's take a look at it. Because I know it's out there. All right. Good now? Or no? Okay. Okay. Okay, technically on this guy, you only have 2 factors, 2 different factors, x and x minus 3. So again, watch. X times x minus 3. X times x minus 3. This whole thing is there. Take it out. You're left with just a 3. I don't know what they do here, but they're just crossing things. I just crossed them out as they showed us. Over here, I got to take out the x. I'm left with 4 times x minus 3. And now I'm going to take out the x minus 3. I'm just left with x. Because we did our domain from the beginning, we did our domain the first day, we noticed that we couldn't use 0 or 3. Well, the answer is 3. Therefore, there's going to be no solution. Always check your denominators to make sure that it's going to work. Whether your answer works or not, that's if you did everything right, it'll work. But make sure that your denominators make it work. So we call this the extraneous solution. It is an answer to our equation, but not an answer to our problem.
So you know it's not an answer to the problem because of the domain? Okay.
Because originally we did the domain restrictions, and we said, if we put a 0 here, this denominator becomes 0. If we put a 3 here, this denominator becomes 0. So this 3 is going to make this be a 0, and we can't have that.
And when you check for extraneous roots, would you do the 3 plus 4 parentheses x minus 3, or would you do the 1?
No, you just come to your fraction.
Okay.
All you need to do is check your denominators for your extraneous root.
Okay.
Extraneous root means you worked everything out perfectly. This is what my answer came out to be. However, when I put it back into my problem, up in your original problem, it's not going to, the denominator's not going to work.
Okay.
But our domain restriction tells us that. Okay. You'll get used to, that's why I spend a little time on domains. You'll get used to the domains. These guys, set them equal to each other. My goal here is to make sure you remember that on a graph, it has an xy coordinate. Just because you found the x, make sure you go back and find the y. These were 2 lines. 2 lines can intersect once, infinite or never. They could be the same line, infinite or never. They could be parallel. These cross once. Just make sure when you find the x that you go back and find the y. And check them on your calculator. You all know how to graph those, right? You know how to do the intersect? I tend to use my y equals a lot. Like on these problems, if you put this into your y1 with your answer and you put this into your y2, you'll figure out where they cross, if they do or not. I tend to use my calculator a lot. Okay, this one, I solved this one for y, the book did, solved it for y, solved this one for y, and then set my y's equal to each other, substitution. Once you set your y's equal to each other, you're going to have to refactor, put everything to one side, refactor. When you get your x's, make sure, these are your x's, make sure you get your corresponding y's. You have a parabola and a line, can cross once, twice, or not at all. And then graphically, if you have a calculator, great. If not, if you have a homework problem and you don't have a calculator, when you come in, just grab a calculator and do those real fast. Hopefully we'll be assigning calculators. I haven't gotten the sheet yet. If you have a friend or a sibling that has a calculator, it's good to get a hold of it. It's good to have a calculator because we use your calculator all the time. And those are the answers. For class, I make them simple. They're steps. I like to do the problems together, follow the steps as easy as possible. I hate memorizing unless I say to you, you have to memorize this, which is very rare. Trying to get the feel of things rather than memorize. So the first thing we're going to do is we're going to look for any domain restrictions. And it's probably, if we have two radicals, it's going to be like yesterday's, where we have to do it twice and see where do they overlap. We're going to isolate your radicals, one to each side. Then we're going to square both sides. Now, when you square both sides, they may not eliminate both of them. You may have to do it again, depending on where the radicals fall. And because we square both sides and we force everything to be positive, we definitely have to check our answers. Kind of like an absolute value, anything that you take a square root of, that you do these things, you're going to have to check all your solutions. So let's start with the real basic one. All right, so the first thing we're going to do is look for a domain restriction. So we take this guy out of here, and we say, we're okay with the 0, but we're not okay with the negative number. So we're going to subtract 7 and divide by 2. So our domain is from negative 7/2 to infinity. Now, the next thing we're going to do is isolate the radical. For you to square that radical, you want to square it all by itself. That's what's going to get rid of your radical. So we're going to, was this a subtract x? I wrote right over it. It said subtract x? Okay, thank you. So we're going to add x to both sides. Now we're going to square both sides. This is going to get rid of your radical. Square both sides. When you square this one, the radical pops right out. These look familiar. Did you guys do these last year? A little bit, yeah. Did you do radicals on both sides? Baker's kids?
I don't think so. I think we only did it.
Baker's kids? Really?
Because
Okay. All right. So when I square that, I get x squared plus 4. Do I get x squared plus 4? No. Good. Don't fall into that trap. Do not do x squared plus 4. This is x plus 2 times x plus 2. Okay, don't fall into that trap. I have so many kids that fall into that trap. Okay, so I get x squared plus 2x plus 2x plus 4. And I got to move everything to one side. I have a radical with a, resolve this. I've got a quadratic, so I subtract 2x. And I factor. Factors, anybody come up with the factors?
X plus 3, x minus 1.
Good. X plus 3, x minus 1. I want my middle term to be higher, so the higher one's going to go here. Okay, set them both equal to 0. So x is negative 3, and x is positive 1. Now, just because it's a negative, it doesn't get rejected. What you have to do is go plug it back into the original equation. So when I ask you to check, I'm not asking, God bless you, I don't need a formal check. I just need you to go back in and do it. Even mental math is fine. Negative 3 times 2 is negative 6, plus 1 is, plus 7 is 1. Square root of 1 is 1. 1 minus a negative 3 is what? Negative 2. So does this work? No. Wait a minute. 1 minus a negative 3. That'd be a positive 4, right? Is this a negative here? I wrote right over it. Yeah. So 1 minus a negative, I'm checking your negative 3. So this guy doesn't work. Not because it's a negative, but because it doesn't fit back in. Sometimes, like this negative worked out okay under this radical sign. So don't fall into that trap. It's a negative, reject it. Fit it back in. So now try the 1. This gives me 9, this gives me 3, and 3 minus 1 is 2. So my solution is 1. Okay, say reject. And we're good to go. It makes sense? You manipulate this radical when you square both sides. When you square it, you manipulate this radical. So you have to check your answers. Not just a domain check, an answer check. Now, according to my domain, it's good from negative 7/2, which is negative 3.5. So technically, it was within my domain. But because we manipulate this along the way, it doesn't always work. Yes?
Isn't it like an irreversible process? So like, you can't use it in the first equation.
It only works in the second one.
That's why you got the second.
Here. Wait.
Like the x something to 3, is that why you got it? Because
Well, we factored this.
yeah. So when you have radicals.
So I'm not sure I understand, Anthony, what you're asking me.
That only happens with like radicals.
With radical, it happens with radicals. It happens with absolute values. Anything where we manipulate the signs on them. Because we're squaring something that maybe was a negative thing, but we couldn't use a negative. So radicals and absolute values you're going to find really, really similar. Okay, let's see if we can get to this one. All right. All right, so now, domain first. I've got a 2x plus 6, and I've got an x plus 4. So I subtract 6, and I divide by 2. X is greater than or equal to negative 3. I subtract 4. X is greater than or equal to negative 4. Now, let me just put this on my number line. What's my restricted domain going to be? So if I take that negative 4 and I plug it into here, negative 4 times 2 is negative 8. Negative 8 plus 6 is negative 2. So I can't use that. I have to use what? Where they overlap. Because this one only works for one of them, not for both. So my domain is negative 3 to infinity. Okay. So now we're going to isolate to radical, which means I have to add, I'm going to add this one to that side. You have to have a radical on each side of the equal sign. This is like worst case scenario. This is not the easy one. So next step, get rid of your radicals. Square both sides. Not your radical, both sides. Just like we squared your x plus 2, both sides.
Why wouldn't it be 1 minus square root of x equals 4?
Because, is this a minus?
Yeah.
I have to add to both sides.
Oh, yeah.
Yeah, I have to add. Sometimes I stand too close and it's very blurry when I stand here, so my minuses, these pluses look like minuses to me. So if I am off, just let me know. But that one we'd have to add to both sides. So make sure you square both sides. Now this one again doesn't come out to be 1 plus x plus 4, right? Because we knew from the x plus 2 we had to write this guy out. We have to do this out, distribute it out. It's not the easy one. That's like when we did this one, we had to say x plus 2 times x plus 2. It would be nice if we didn't have to, but we do. So we drop this guy out, and we distribute this. So we get 1 plus 1 of these, 2 of these. And what happens when we multiply a radical times a radical?
You remove the radical.
We remove the radical. Good. Okay, now, before we do anything else, let's collect the like terms on the right side. We got a lot of things going on. So a 1 and a 4 gives us what? God bless you. This is your worst case scenario. It won't get any worse than this. You're only going to have maximum 2 radicals to deal with. So now we're going to move everything but the radical. We need to go through those steps again. We need to isolate the radical. So we're going to remove 5 and x from this side. Now when I isolate the radical, if I could divide by 2 and make it go in evenly, I would. Like if it said 2x plus 2, I could divide both of them by 2. I'd get rid of the 2. But if it's going to make a fraction, leave it there, because you can square it just as easy. You know what I'm saying? So if it's easy to divide, divide and get rid of it. If not, square both sides. So again, this is x plus 1 times x plus 1. This is x squared plus 2x plus 1. And this guy, you have to square 2 as well. So 2 squared is 4 times x plus 4. Yeah, this is worst case scenario. This one takes a little longer because you gotta pretty much cycle through this twice. So this is, I'm just gonna cheat over here and say 4x plus 16, if that's okay? So we're gonna subtract 4x and we're gonna subtract 16. Oops. 4x. Okay, I'm gonna move it over here. Factors? Everybody? Good. Okay, and x is equal to 5, and x is equal to negative 3. And negative 3 is in my domain, 5 is in my domain, but I have to go back and check my original equation and make sure that it works. I'm looking to see was one of these an extraneous root. So this half of the room, check 5, and this half of the room, check negative 3. Yes.
At the very bottom of the screen in the middle, is that a line
At the very bottom here,
Yeah. I think it was.
this x squared plus 2x plus 1 equals 4x plus 16. I just kind of cheated and wrote it on top.
Oh, like the one that's crossed out.
Okay, that says negative 4x. I subtracted the 4x and subtracted the 16. So I got x squared minus 2x minus 15. I wrote it over there because I know you can't see it. The problem when I use colors, then I can't move the board. Then it makes me erase it.
5
the -3 doesn't work. Now the -3 doesn't work, not because it's a negative, but because when we put it back in, it's not working. So we reject this, and we have one solution. Okay? This will probably be the longest one that you're going to do with 2 radicals.